Hi, I'm Alex Clemens, and this is a video on cortical remapping in phantom limb syndrome and associated phenomena. Studies suggest that phantom limb syndrome arises from the remapping of primary motor and sensory cortex that was formerly dedicated to the amputated limb onto adjacent areas of the Penfield sensory map. This means that if an arm was amputated, for instance, the area corresponding to the amputated hand still exists in the brain, but is stimulated by contact with parts of the face, which is what is adjacent to it on the Penfield sensory map. This has been observed in monkeys and in human case studies, particularly in the case of an amputee named Tom, described by V.S. Ramachandran in Phantoms in the Brain. There's also evidence that both motor and sensory cortex is involved in this phenomenon, and the evidence for the influence of primary somatosensory cortex comes from a paper by a team of researchers led by Matthew Longo, who discovered that transcranial magnetic stimulation of the associated area created sensations of movement in the phantom limb. Earlier hypotheses for what causes phantom limb syndrome include delusions, a desire to have the limb back, an activation of destroyed nerve endings called neuromas in the stump, and misrepresented motor output to the stump, which is one of the hypotheses forwarded by Longo. Voluntary control of phantom limb movement exists and is hypothesized to be mediated by the relevant area of primary motor cortex. It can sometimes involve perceptions of global movement of a phantom limb. The case of Ramachandran's subject, codenamed Tom, is a prime example of this. And then something interesting that sometimes occurs is that people will have a sensation of movement of just a phantom hand, but transcranial magnetic stimulation of primary motor cortex can restore voluntary movement of the phantom limb to all joints. The perception of phantom limb movement is caused by stimulation of the part of primary motor cortex that corresponds to the amputated hand. This was demonstrated in a 2006 paper in the journal Brain. Transcranial magnetic stimulation of the affected area of primary motor cortex caused perception of movement in 3 amputees. It can also cause perception of phantom limb movements that can no longer be done voluntarily. Some evidence, particularly that described by V.S. Ramachandran, suggests that stimulating parts of the face can cause sensation of touch in phantoms. This is mostly replicable in studies of monkeys, but a paper from 2001 reports that it can also be found in humans and is most likely associated with stimulation of the remaining stump neurons.